So now let's talk about normal distribution. So this is a really important thing that we are going to do throughout the rest of this course. So normal distribution is a way that we can estimate populations easier, and it's based on calculus. But of course, in this course, you're not going to have to use calculus. We use Minitab to help us. So we're going to make assumptions. For normal distribution and normality test, you are only using continuous data. No discrete data can be used since there's interval between the values. So what does that mean? That means you need to have data that could have decimals and fractions in it. So the normal distribution has two parameters we have to think about, which the parameters are really just two numeric description measures. The mean, which we write with this little mu sign, and the population standard deviation, which we write with this little sign, the population. So if X is a quantity to be measured that has a normal distribution with a mean and a standard deviation, we designate this by writing the distribution approximates the normal, comma, with the mean and the standard deviation. And over here is the shape of the normal distribution. It's that bell-shaped curve. And notice it's not touching the edges. The edges will go really, really close to the x-axis, but they'll never touch. So this section presents methods of working with normal distribution that are not standard. So what does that mean? The mean is not 0 and the standard deviation is not 1 or both. The key concept is that we're going to transform the original value x to a standard normal distribution by using the following formula. Okay, so what does this mean? So this means that we're going to take, there's this table called the standard normal distribution table, and we're going to take actual data, we're going to transform it using this formula so that it can fit on that standard normal table. So we are going to do, it's called the Z-score. I'm hoping you remember this from 1401. So the Z-score equals the original value minus the mean over the standard deviation, and we round the Z-score to 2 decimal places. Okay, so basically, again, what we're doing is I have this regular data that I have a mean and a standard deviation and an x value. I put it through the Z-score formula and it transforms it so it's on the standard normal distribution where the mean is 0 and I have Z-score values. Okay, using the Z-score. So suppose my distribution approximates the normal with a mean of 5 and a standard deviation of 6. Suppose x equals 17, find the Z-score and interpret what that means, and suppose x is 1 and find the Z-score and interpret what that means. Okay, for the 17, the Z-score is 2, so that it is 2 standard deviations above or to the right of the mean, which equals 5, since the standard deviation is 6. So how am I getting that? So let me show you. All right, so when I put the formula in, remember I got Z equals the value minus the mean divided by the standard deviation. Okay, so then I'm going to do Z equals the value, which was 17 minus 5 divided by 6. So if I keep going with that, I get Z equals 12 divided by 6, or Z equals 2. That's how I got that. So I'm going to get rid of this here because I think it makes better sense if I do that. Okay, so how about, or I'm going to go back to the current slide. So what are we going to do for x equals 1? Okay, I just do the same thing and I get a Z-score of negative 0.67. What does that mean? That means for that data value of 1, it is 0.67 standard deviations below or to the left of the mean. So that's all it means. Let me get rid of the other stuff because I don't like how this is doing. Okay, that's all it means. That's all you need to know. That's it. So you just use the formula and it tells you where it is. It's based on this rule here too, that the empirical rule. And the empirical rule is pretty cool because it lets me divide data into certain parts so I can make estimations. So remember, I'm using my standard normal distribution. 0 is the mean in the middle. And I can go from -1 to 1, which is 1 standard deviation away from the mean. Because remember, what happens on the left of the mean has got to happen on the right of the mean. So 1 standard deviation from the mean contains 68% of the data. If we added 34 plus 34, we get 68%. Now, if we keep going 2 standard deviations from the mean, it's this like dark pink, light pink, and dark pink. If I add that together, I get 95% of the data go from -2 to 2. And then if I want to do the remaining, if I go from the blue to the blue, which is 3 standard deviations, I get 99.7. These little tails right here are are the remaining 0.3%. So this altogether equals 100%. You don't have to worry about memorizing this because Minitab is going to do what we need for us.